Good morning, everyone, and welcome to this latest session in the Faculty of Engineering's Research Showcase. And this morning, we'll be talking about the future of robotics. My name is Arthur Richards. I am Professor of Robotics Control at University of Bristol and also co-director of the Bristol Robotics Lab, which is joint with the University of the West of England. I'll be chairing today's discussion, so I'll be keeping my opinions, sitting on my opinions firmly, but I do get the reward of being able to give my colleagues a hard time. If I might begin by asking my colleagues on the panel to briefly introduce themselves, and we'll start with Jonathan, please.
Hi, my name is Jonathan Roster. I'm Professor of Robotics at the University of Bristol, and I lead the Soft Robotics Group at BRL.
Nathan.
Hi, I'm Nathan Lepora. I'm a Professor of Robotics and AI at the University of Bristol and Bristol Robotics Laboratory. I lead the Tactile Robotics Group at BRL.
Sabine.
I'm Sabine Howard. I'm Associate Professor of Swarm Engineering at the University of Bristol, and I lead the Swarm Robotics team at the Bristol Robotics Laboratory.
And Manuel.
Morning, everybody. I'm the outlier. So my name is Manuel Giuliani. I'm a professor at the University of West of England in cognition for robotics.
No one's an outlier here, Manuel. But, in a moment, I'm going to ask each of my colleagues to go around, so each of our panelists to give a short introduction to their work and to their vision for robotics and to their feelings about this big question about the future of robotics. While they're doing that, please feel free to post your questions using the Q&A function in Zoom. And then after all of our colleagues have spoken, we'll start putting your questions to the panel. So if I can begin then, I'll mix the order up this time. So let's start with Sabine.
Great, sure. So as mentioned, I'm Associate Professor of Swarm Engineering, and really what my day job is to make robots that work together in large numbers. So if you look at swarms in nature, you might see birds or bees or ants or even our cellular systems. They're capable of incredibly sophisticated collective behaviors. They can build structures, they can grow functional shapes, they can search environments, they can make decisions, they can move as collectives. And things that are interesting for the real world in terms of engineering, well, they can scale to huge numbers, they're robust to individual failure, and they can adapt to the world that they live in. So how do they do it? Well, they do it by having every individual react basically to the world around them. There's really no leader telling every agent what to do. And so our puzzle as swarm engineers is to figure out how we design these agents and how they react to the world around them so that the collective, these large numbers, do what we want them to do as a team. So the community, I'm sure you've heard of swarming before. The community has been working in swarm robotics for a long time, for 30 years now. And most of this work has been done in the laboratory. I think now is actually the time to bring these swarms to people, to bring them to the real world. And the reason for that is that what I'm seeing is a perfect storm brewing. Basically, we now have the ability to mass produce low cost, yet quite capable and sophisticated robots that can understand the world around them, their local environment. Second, we have access to faster than ever inter-robot communication and communication with the outside world as well, which makes it possible for these robots to interact with each other and ourselves, and also allows us to get real-time data for things like digital twins. And third, we have swarm algorithms that we've been building up over a long time. These 30 years have been built up to this moment where we actually know how to design swarm rules. And we actually use machine learning very often to be able to come up with these rules in real time for the task at hand. So where are we using this perfect storm basically in our swarm team? Well, currently we're building a new test bed in collaboration with Toshiba, which will be accessible remotely for swarm logistics. So we have 20 new sort of bespoke state-of-the-art robots that are zipping around and helping us organize space or warehouses. You can think of it that way. The way we're thinking about these swarm solutions is really as out-of-the-box strategies, things that people would buy, take out of the box, and would be used in places where there's an unmet need. So that could be a retail shop, a small retail, it could be a warehouse, it could be a pop-up COVID distribution center. So these are places where automation has not yet arrived because there isn't a solution that's easy to take out of the box, that adapts to the environment at hand, and that requires zero skills or zero setup. We also are working on swarms of drones for things like fire monitoring and mitigation. And lately we've built 100 little screens on wheels, and we're working with these robots to see how they can help humans brainstorm and reach consensus, sort of a new platform that allows humans and robot swarms to play together to hopefully work as teams, as a bigger team, in a more efficient way. And if we had more time, I'd also tell you about our work doing micro nanosystems for cancer. All right, so what's the challenge? Well, I think it's about bringing it to people. How do we make these trustworthy? How do we make these safe? How do we make sure people understand what these swarms are doing and interact? And maybe we'll get to chat about that a little bit more.
Thank you, Sabine. Let's go to Jonathan next, please.
I don't know how I can follow that. Thank you, Sabine. So my name is indeed Jonathan, and I work in soft robotics. Now, soft robotics is slightly different to conventional robotic systems, which traditionally you'd think of as hard, using metal, using gearboxes and so on, the kind of thing that you would see in a manufacturing plant at the moment. And it's really interesting if you go into, for example, a car manufacturing plant, you'll see these big robots on one side of the plant, and then the other side is where there are people, and the people are doing lots of manual work. So my job really as a roboticist working in soft robots is to try to bridge that gap between what is a kind of an industrial process and what is a human-centered process. And so we work on soft materials and soft structures which are compliant and adaptable, and they don't use motors and gearboxes. They use smart materials which are like artificial muscles. And that means that these structures are more useful for interacting with people and with the environment. You can imagine that if you were going to make an exoskeleton, for example, there are lots available at the moment, but they're really hard, rigid kind of structures, and they're not comfortable. And yet, if you look all around us, my chair is soft and my bed is soft and my clothing is soft. So humans naturally interact in those kind of environments. So if you want to have a system which is going to assist somebody on a production line to put a widget into a car, for example, we would expect to see an exoskeleton which is soft and compliant. So there are real challenges, but opportunities here. And those kind of materials, I feel, are missing something. What they're missing is they're missing the three components of adaptability, artificially intelligent structures, and autonomy. So one of my jobs is to make new materials and structures that are intelligent and adaptable. Now, one thing about materials like this is that in nature, there is a whole variety of structures that are soft and compliant that have intelligence embodied in them. And we don't have that yet. So one of the challenges for me is to turn materials into intelligent materials. And that would then have a great impact on healthcare, for example. Imagine something that you could implant into a body and that would assist your movement. And we're working towards that through our MPOWER project, which by 2050, that's 30-year time frame, we'll be implanting artificial muscles into people. Now, at the same time, these robots can be made soft and compliant and biodegradable and edible even. Now, if you can make an edible robot, then that changes the way in which you think about robots and what they can do. So imagine that you have some food on the plate and it's moving around. That could attract some younger children to eat it, but also for those who are older and they have problems with swallowing, then they can use those robot foods to move through the mouth and to swallow themselves. So if we look at the future, I think robots are going to be completely ubiquitous, and soft robots enables us to move towards that. If you look at the numbers of robots that we're making at the moment, they're in the millions, kind of in the millions of robots per year, and yet we have the opportunity to increase the numbers. If you look at the human body, there are 40 trillion bacteria in the human body, and yet there are 30 trillion human cells. So you're more bacteria really in your body than you are human cells, yourself. Now, if you were to make robots that are going to be small and compliant and soft and the size of bacteria, then you can imagine in the future that there'll be more robots inside you, if they would do the same kind of work as bacteria, than human cells. Now, this is really exciting. So I feel like in the future, one of the challenges is to make our soft robots smaller and more effective and more compliant, but also to be more ubiquitous. In the end, we probably won't even use the term robot because it'll be around us and part of our lives.
Thank you, Jonathan. Let's go to Manuel next, please.
I mean, that's a perfect segue for my research area, which is human-robot interaction. So in human-robot interaction, we look at the name tells it already, how humans and robots will interact with each other in the future. And so the segue is there because, as Jonathan says, and I think Sabine also already hinted at it, we expect that there will be robots everywhere in our future. We will have robots in completely new application areas, and especially we will have robots in application areas where robots will meet humans who have not been trained to use robots. So in the past, we just had industrial robots behind barriers somewhere in a factory, and we had people who programmed these robots and were specifically trained to do that. And in the future, we will have robots, being in the presence of humans who have never received any training to use a robot. And for that, we need to look into how robots can actually understand humans, how robots can interact with humans in a socially acceptable way, using modalities that humans can understand, like language, like gestures, like postures. We also need to look into what forms robots need to have, so that humans can work with these robots in a usable and sensible way. So human-robot interaction has always two parts to it. On the one hand, we have a technical part where we build robot systems in terms of hardware and the software needed to interact with humans, and that is that is quite challenging in itself already, because something like social interaction is probably one of the most cognitive challenging skills that humans have, and things like free-form dialogue, or free-flow dialogue, where you jump between topics and talk about different things and you plan things and so on, is not easy at all. So building that into a system to understand humans and work with humans is really challenging. And the other part in human-robot interaction is always to look at how do humans actually use these systems then once you have built them. And for that, we already go, we use methodology from the humanities, from psychology and so on, to do participant-facing studies, where we look into how humans perceive working with robots, how they perceive the robots in terms of trust, in terms of perceived intelligence, in terms of perceived safety, and usability, and all of these more abstract concepts that are not always measurable in an easy way, in a straightforward way. So just long story short, human-robot interaction is the field that looks at how to make robots usable to humans.
Thank you, Manuel. And finally, we'll go to Nathan.
Hi, so I'm just going to share my screen. Yep, so hi, so I'm Nathan Lepora. So I'd like to discuss the implications of AI and, have I screened in Spanish? Discuss the implications of AI for robotics, which is my research area. So, I mean, we're all very familiar that there's been a revolution in AI. You can't escape it, almost every other story in the media is about how AI is affecting our lives. It's pervasive in our phones, in our internet, and our technology now. What's maybe not so well appreciated is there's been a revolution in robotics over the last 20 years, specifically in the area of AI applied to robot vision. So we have driverless cars on our roads. Yep, driving around because of AI. So that would have seemed unthinkable 20 years ago. But it's reality. It's in our lives. It's on our roads. Now that same technology that allows AI to drive cars has also led to a revolution in other autonomous vehicle technologies, such as drones, civilian drones, military drones. So which is causing profound implications for our lives, society. But that is a mature revolution. The cars are on our roads, the drones are in our skies. Now the revolution that I think will be more profound in terms of our lives, that is just starting, but is really gathering pace at an enormously rapid rate, is the AI revolution for robot dexterity. So what is happening at the moment in the field of robotics is there's enormous translation of academic research into industrial research going on here and now, specifically into the areas of warehousing and logistics. So now we're talking like Amazon, Ocado, big company, Google, big companies like that. It almost seems like every other week, there's a new startup coming out of Silicon Valley with hundreds of millions, led by some, big roboticist in manipulation. There's enormous activity going on in this area. So my view is that is going to work through quite quickly because of the enormous resources being put into the area. The next stage of that, the natural evolution of that, will be towards robots handling objects and items with the ease of dexterity that humans have. That's the natural progression of that revolution in robot dexterity that's currently taking place. Now that, once complete, will have enormously profound implications for our society, because basically any task, any physical task that can currently be done by humans will be possible by robots. That is the implication of that revolution working its way through. Now, it may seem like science fiction now, but just as, cars seemed like science fiction 15, 20 years ago, autonomous cars, and then were on us almost before we knew it. I think similarly, this revolution in robot dexterity is going to be on us before we think about it. And we're looking potentially at the end of this decade before, it's here, it's happening, and it's starting to influence our lives, and then will become a pervasive aspect of our lives and society and economy next decade. So now is the time to start thinking about the implications of this for our lives, because it's going to be on us before we know it. And as I say, will have profound implications, at the level of, say, the industrial, communication and intelligence revolution that have taken place over the last century or so. Okay, thank you.
Thank you, Nathan. If you could take your screen off as well. Thank you very much. Okay, so there's a couple of questions coming in. I'm going to leave it a couple more minutes for the questions to build up and people responding to that. But I'm going to award myself the opportunity of the first question. There's nobody here who's sort of new to robotics in a way. And so I think 10 years ago, we possibly would have said lots of the same stuff about, oh, it's coming, robots are going to be everywhere and so on. And somewhat provocatively, what we have is this. Well, that's great fun, but who actually wanted a dancing dog? So my question for the panelists is, when is robotics going to live up to its hype, and will it? Does anyone want to go first on that? I'll come to you in a minute, Nathan.
Well, Arthur, you've gone quiet, so I'm assuming it's me. So the first thing I'd like to say is that's a perfect example, right? If you want to make something scary, what do? You make a robot dog, and then you put a robot snake on the top of it. Okay, so it is a bit of hype, and hyperbole is something that all industries have been facing. But that is a great example whereby building on established technologies and just incremental development has led to that device, which is starting to have an impact. And it's starting to have an impact because you can go out to Massachusetts and they're using it for patrolling with the police. Now, okay, put aside the ethics of using it in a military or police role, in terms of using it for practical applications, that's pretty darn good. So I feel like we have reached not the crest, but we're cresting with the capabilities of robots that actually we're way beyond what we were 10 years ago. We're not dreaming it, we're actually living it, but only at an early stage. It's like the start of the Industrial Revolution when the first trains came. That's where we are. Okay, we don't have intercity 125s, but we have the steam train, and you can get from Bristol to London pretty easily.
Thank you, Jonathan. Nathan, you said you wanted to respond.
So I think this question fits in quite well with some of the points I was just saying about the translation into industrial research, and particularly in logistics. So I'm going to share my screen. So this article literally came out in the last few days. So in it, I learned that Boston Dynamics, obviously, who are famous for their, dancing quadruped dog-like robots, they're pivoting their company towards logistics, the kind of things I was just covering. So this is their new robot that's coming out, which is called Stretch, taking one of the Spot robots out of a box. So I'll follow up Arthur's video with another one. So this is their Stretch robot, which is their solution for logistics and warehousing. And this is one of these big players who I was just talking about, who are, actively driving forward this domain. And this is the kind of thing you can imagine in a warehouse, or in a shipping depot, transporting boxes, and is the kind of thing that is going to revolutionize the logistics industry. Amazon, Ocado are going to be buying these things or developing themselves in competition with this company. So I guess to kind of finish that, the companies have gone past these nice demos and are now firmly, focusing on the industrial translation of that research and making money, which is in the area of logistics at the moment.
Thank you, Nathan. Manuel.
Yeah, well, the point I wanted to make is very similar to what Jonathan and Nathan said. I think we are I mean, your question was, is robotics technology is just a hype, right? Or is it where are we with it now? So the technology is getting more and more mature. We are now at the point where companies will hopefully pick it up, the technology, and turn it into useful products. I think so. In the past, so from a social robotics, human robot interaction standpoint, we have seen a few companies now that try to establish robot companions, social companions, as a product. I think the probably the most that had the most hype or most press up behind it is Jibo. Maybe you remember this one, which was marketed as a competitor to Google Assistant and Amazon Alexa, but with a robot body. And the question from the start with this kind of product was, how is that usable? What is the difference, or how is that better than Amazon Alexa, for example? So I think the question will be, how do you take the now getting more and more mature technology and turn it into something that's actually doing something useful? And it seems like warehouse and logistics is the next step. And then, well, it needs to be figured out where we are going after that.
Thank you, Manuel. And finally to Sabine on hype, please.
So I think very often when people see Spot, that robot dog, they see that as a robot that they will never encounter or own, because it's a robot that's 50,000 pounds. And so it's something that's out of the reach of most people or companies. And when you look at those more sophisticated logistics robots, I think there's amazing technology in there. And what we're doing is complexifying and adding more and more intelligence to those individual robots as a way of making them deal with the real world. But the real successes, the things that lowered the hype, are the robot vacuum cleaners. So what I want us to have now is sort of the Roomba for multi-robot systems. So the Roomba is that little vacuum cleaner, the initial one that just bounced off walls and did things simple, but well enough that people would buy it. It was cheap enough that people would use it. And so I think we're also in a state where maybe the complexifying, making more and more intelligent, is not the thing that's going to get us to people in a de-hyped way, but it's maybe these simpler robot solutions, if we can crack it. So that's my only comment, is we need to get these technologies to people rather than show off the more and more sophisticated robots, because those are a little bit out of reach for most.
Thank you, Sabine. Nathan, we're going to move on because we've got some questions from the audience. So thank you very much for your thoughts on that. But what order shall I do these in? I'm going to take them out of order because I think some of them follow. So actually, I'm going to start, if I may, with the question from Richard Cunningham, which is down at the bottom. So we will come to the others. Apologies to those. They've been very patient, and we'll get to your questions. But Jonathan set this one up by saying, put the ethics to one side for a moment. And Richard has come back straight away quite nicely and said, well, where does ethics sit in your thinking? And how, with the dramatic increase in capabilities of robotics and AI, how real are the concerns expressed by the likes of Hawking and Musk, and where does ethics sit in your thinking? So I'll take that one straight to Jonathan, and then we'll let other panelists join in as they would like to.
Yeah, you pushed me into a corner there, Arthur. I didn't say that we should put ethics to one side for that particular example. I think that's an example where we can't put ethics to one side. That's not included in the videos. But, and as Sabine kind of touched upon earlier, it's trustworthiness. And that is this kind of overarching theme that we tend to use. And it includes ethics, and it includes equality and diversity and applications and so on. So we absolutely need to consider ethics. But one of the challenges is, even if you have an ethics application, people may not want to use that robot because they don't trust it. So one of the challenges really is making sure that the humans on one side and the robots on the other side will work together, because the humans trust the robot and the robot is doing something predictably, safely, and they are happy with it. And that's something which is much more a human factors end of things, which is core to getting robots into the environment. If you look at the debacle with genetic modification, for example, here we've learned from that, and we're saying exactly that right at the beginning. Now we need to talk about ethics, trustworthiness, safety, and so on.
Thanks, Jonathan. And can I take this one to Nathan as well, please, given that there was a question about, part of it was about growth in AI.
I think we need to be careful that we're asking the right ethics questions, because there are important ethics and societal implications of the robotics that's happening now. Now, the ethics debate is currently being driven by the ethics debate in AI, which is very active within that field. So last week, I gave a talk at the Turing AI conference. The theme of that conference was basically dominated by ethics of AI, because AI communicates with humans, affects our behavior, and so it's important, the ethical implications of how it does that. I was the only roboticist at the conference, and maybe there was one other tucked away and I was put there actually by mistake, because somebody had a book titled Robot in it about ethics of AI, but they were using robot wrongly because it wasn't a physical robot, it was an AI agent. So I think we need to, as a robotics community, we should be careful we're not being influenced overly by the ethics debate that's happening in AI, because I think there's distinct ethics debates in robotics, and particularly it's around the age-old issues of displacing human workers and so on, as you're seeing happening in the Amazon. There's a lot of furore about that. It's those kind of questions that I think we will need good answers to as robotics progresses. I think we should, avoid the temptation to get too much into, how much, the AI ethics debate, which is, in my view, quite a distinct debate about how it's affecting human behaviour and our morals and values.
Okay, thank you, Nathan. I'm going to move on in the questions. I'm going to move to one from Simon C, who has waited very patiently with their question right from the outset. How much does bio-inspiration in robotics define the future? And I'll take that one to Sabine in the first outset, please.
So bioinspiration is a great tool because nature has found very interesting solutions to a number of the problems that we're asking of engineered systems. I mean, we are biological agents, and the world has been built for us and other biological agents around us. So we use bioinspiration to get ideas, really. I think we don't do this in a religious way. If there is no bioinspiration for a specific problem that we're asking, then we'll engineer it. We'll use machine learning or other tools to be able to wrap our head around that. But nature is a great source of inspiration, and we use it all the time. And so we work a lot with biologists actually to crack that. And I think the next frontier is very much bio-inspired. So this notion of cooperation and things that work together, which in my world is inspired from swarms. Maybe Jonathan on the soft robotic side, it's profoundly inspired from the way we're built of soft materials. And we actually have an MSc as well in this area in biorobotics, because we think that's going to offer new solutions for the way we design some of these robots. in the future. So we're not religious about it, but very excited about bioinspiration, and it has served us well.
Thank you, Sabine. I'm going to press on through some of the audience questions. So I'll tell you what, I'm going to take the next one from Vishnu Jayan, who asked, how advanced are we going to learn computer vision, AI, and deep learning in MSc Robotics at University of Bristol? Does computer vision AI engineers have a good scope in the UK? So Vishnu, I'm not quite clear what you mean by the second part of your question. So I think the answer is yes. I mean, there's lots and lots of employment opportunities and research opportunities in that field in the UK. But just to touch on the education issue, so Vishnu points out that we have a joint MSc between UE and Bristol that's run through Bristol Robotics Lab. And so I'll ask a slightly broader question of Nathan and Manuel, both of whom are past program directors of that, to talk a little bit about what kind of things are important in education and what students might expect to find and what levels of things are in that course. Manuel first, perhaps.
Well, I mean, to concretely answer the Vishnu's question, we do have deep learning and machine vision in the MSc Robotics program. We have it right now. We already had it, I think from the start. And in terms of how deep can you go, it's a 1-year master program, and the goal is really to give the students a broad overview of robotics in different areas, machine vision and deep learning being one of them, and giving the students the tools to learn everything they need to. They can learn about one specific area if they want to go in depth. So we will never be able to give everyone all the tools that you need in robotics, but we are able to give you an overview. There will be, we send the students on the way, and then if they want to get to know about specific aspects more, then they can continue with self-study. But just to answer, we do have quite. I know that many of the MSc Robotics graduates go on and work in machine learning or deep learning in different industries. So I specifically know, personally know, I think 5 students who I know who went on to work in deep learning after doing the MSc Robotics. So it seems that we are giving already a lot of knowledge to the students. Yeah, Nathan, over to you.
I'll comment first on the robotics MSc. So I was program director for it quite a few years before Manuel, so back in 2014. So then there was 8 people on the course, and now with the most successful, and then now with the most successful course in the UK, I believe 130, 140 people, and that's partly obviously we've got a good MSc, fantastic MSc, attract students. But also it represents, the growth in the field and the desirability of that as a qualification. So I would say the key, there's a relationship between AI and robotics and being taught. I would say the key aspect of our robotics MSc is the hands-on robotics experience that we offer, with Bristol Robotics Laboratory and the expertise of our supervisors. So that is absolutely critical for robotics MSc and for robotics education. A lot of the other things, like deep learning, you can learn it online. The tools are fairly easy to pick up. We do teach some of it, but if you like, the real value that you get from our course, as I say, is really the hands-on experience at using real physical robots to see what they do.
Thank you, Nathan. So I'm going to move on to Marina Constatatu's question, who asks, in terms of robotics in construction, where do you think we are in terms of robotic assembly systems operating and recognizing uncalibrated terrains? I'm going to ping that one. Well, I'll take that to Sabine, and then perhaps we'll come to Nathan in a minute as well for the dexterity angle. Sabine, over to you.
So that's something that we've started to explore from a multi-robot swarm robotics perspective. If you think of building a wall, the rules are actually quite simple. You lay a brick and then you lay another brick and then you lay another brick. And a system where you would have many robots could, has the potential to scale nicely in terms of how that would speed up the process. And in terms of recognizing the uneven terrain, there's potential there because it's local to basically change the way you're laying those bricks based on the terrain that you're encountering. So I think there is potential there to think differently than those big robot arms that might be laying the bricks all around the house. And that causes things to be a bit restricted in how big your house is or what kind of house you can make by having many robots work together to do that work. I think there's also a shift in what a house might look like as a result of it. So maybe your house has walls that are a little bit different, or maybe your house has little windows because that's where the light was hitting and the robots thought that would be a nice place for the sunlight to come through. So I think when we think about these technologies a little bit differently, it also changes what we think the world around us might look like as a result of that.
Thank you, Sabine. I did try to build a wall once, and it turns out it's not nearly as simple as that, and it did indeed look a little bit different.
Fair enough.
So, Nathan, over to you.
It's a really interesting question, and and I completely agree with what Sabine is saying as well. I mean, wow. I mean, this has the opportunity to be a really revolutionary, development as robots start doing our construction. So my personal view on this is we're kind of at a minimum, a lull, a worst period in terms of building houses. So, I mean, we live in Bristol, and I think it's clear to everybody that the Victorian houses are a lot better built than the modern houses. And that's basically because the amount of human labour and the cost of human labour have got a lot higher. But, all this individual construction in the Victorian houses was possible. Now, wouldn't it be amazing if robots were to enable a future where we take us out of this lull and we get to the kind of quality of housing that we had in the best houses in the the mansions? It could transform our world. I think it's a really exciting thing. So another little comment I'll make as well. I mean, Sabine mentioned the Roomba vacuum cleaner has been the most pervasive robot. Another pervasive robot is going to be 3D printers, which are basically robots with extruders on the end of them. 3D printing construction is an area that's taking off enormously. You can 3D print concrete, and that as well is another revolutionary development. And I just hope that within my lifetime I see this play through, because I think there could be really exciting things that come out of it.
Thank you, Nathan. So now we're going to move on to a question from John Wakely. Good morning to you, John. So John says, I'm exploring robotic solutions for civil engineering challenges in fiber broadband deployment. Key issue is the business case. Sometimes the complexity, fragility, and operational requirements kill the business case. Does the panel think that robotics developers take enough account of the real world environment and implications for the end-to-end business case? I'll tell you what, I think there's an implication in the question that John asks that perhaps John has a view on that. So I wonder if the production, so I'm going to ask Manuel and then Jonathan to comment on that. But then I'll ask our production team out back to perhaps bring John into the panel so that he can offer his response to that. So Manuel, over to you.
I have the feeling that there are two questions here, right? So do we as robotics developers or researchers take into account the real world environment? And then there's a question about the business case, right? So well, in terms of the real world environment, so we do work together with many industry partners in our research projects and also in our training. So for example, in our FARScope Center for Doctoral Training, we do specifically have industry training for our students, PhD students, built into the program from the start. And every year we do industry trainings and industry weeks where we get partners into to tell our students what the actual challenges are that the industry is facing, so that the students align their research with real problems. The other thing about the business case. So the business case is actually a really hard problem to crack. And again, so just to give you one example, we do work together, for example, in one of my research projects that we're working on. We are closely working together with the nuclear industry on nuclear waste sort and segregation. And And so one of the requirements that the nuclear industry has is that you can only use CE marked robots, off-the-shelf products that you can easily replace. So so we are now doing research only with off-the-shelf robots. So we are not trying to build any new robots for this kind of research where we use the robots for nuclear decommissioning. So so this is just one example where we try to meet the requirements from our industry partners, but still it will be very hard to turn a nuclear sort and segregation robot into a business, into a product, because we're talking about one-off solutions here, where it is hard to earn a lot of money. So so the question about the business case is actually one that I really can't answer. Maybe Jonathan has a good example here where with a better answer. Yeah.
Yeah, I mean, I think for business cases, you need evidence, don't you? So one of the challenges that we face is to provide enough evidence, data, which is close enough to reality for the business case to be made. And that's always going to be a challenge between the kind of research environment and a manufacturing or a user environment. So we need to bridge that gap. And to bridge that gap, the government has put in a lot of funding recently to create centers for smart manufacturing, manufacturing made smarter. And Nathan and I are on a new proposal on that. And it's great to see industry putting in now a lot of dedicated resources to it. So for the proposal that we put in, there's something like 50 industrial partners putting in £3 million, which is almost as much as the grant itself. We've never seen that before. Now, there's a chance with that kind of initiative funded by the government and co-funded by industry where we can bridge the gap between what we're doing and what's needed, and actually to transition some of this research and development from our laboratory into on-site development. You know, talking about John's example there, doing it at the site, you know, getting that development in the ground, in the dirt, as it were. Perhaps John might like to comment.
It looks like we can't bring John online at the moment. So
can you hear me?
He's in.
Oh, no, we can bring John online. Here's John.
Yeah, hi. Thanks for those answers. Very good. And yes, it was a deliberately provocative question initially. And it's from a very narrow perspective of my own use cases, so I accept that. But for the example I was thinking of was if I'm looking at a robot that can go through and remediate blocked ducts or even dig in a new duct, it may be possible to develop a robot that does that absolutely perfectly. But the fact that the OpenReach engineer then picks it up and throws it in the back of the van and breaks it means the whole thing is a nonsense, because I have to then replace them every other week. So I used the term business case deliberately, I guess, for the operational context. It's understanding how things get used by real people in real situations, rather than solutions that are optimized for the task itself. So, because I think we're going to come across this a lot in real field engineering scenarios. And I take Jonathan's point. You're spot on when you say get out there and get it in the dirt and see what happens, because that's the way you learn. I'd just like us all to be a little bit more upfront, taking those into account right at the beginning of the concept and requirements capture process, than doing optimized solutions, taking them out in the field, then finding they don't work because of the context rather than the challenge.
Thank you, John. I think we'll all agree on the panel that yes, I think go back to what Jonathan was saying about ubiquity right at the start. I mean, the problem with ubiquity is it gives you a hell of a lot of context to deal with, and I think that's kind of something we're all quite excited, but also recognise as a big challenge. So we're going to move on now from that question, and we'll move on to a question from Chunghua Liu. Who asks, we all know that machine learning technology has been widely used in the research of robots, but is there a similar adaptation for soft robots? I think that one naturally goes to Jonathan.
That's a superb question. And I'm not just saying that because I want some more thinking time. It is an excellent question. We take a lot of inspiration from nature, and we touched on that a little bit earlier. And the great thing about nature is that it's had millions of years, billions of years to develop effective solutions. We, on the other hand, we've got our smart materials and our machine learning algorithms, and we hope it's going to work. Now, that works pretty well for rigid robots. It becomes more difficult with soft robots because they're that much more complex. When I say complex, I mean that they're soft and squishy, so they can move into all sorts of unpredictable shapes. So there's two things we kind of need. The first is to use machine learning to design those squishy robots and the way that they move. And the other is, yeah, that's great at a design point of view, but what about getting that squishy robot, which is going to go into a duct, for example, as John was mentioning earlier, and clean out the duct, having that robot itself being intelligent. Now, what we could do is put silicon in there, a computer in there, but that's not really in line with soft robots. So instead, we and others are looking at getting intelligence into the materials itself. So the computation is in the structure itself. And that's a little bit more like intelligence in some organisms that exist in nature, fluidic, vascular intelligence. So you're absolutely right. Machine learning is there. The one thing we can do is make our robots control themselves with non-conventional control. But one thing they can't do at the moment is learn. So the next challenge is to make soft robots learn without a computer. They have their own basic material-based computer. So really exciting stuff, and that's probably going to be in the next 20 or 30 years that we really develop things that really will have practical use in that field.
Thank you very much, Jonathan. I'm going to move on now to a question from Kevin Garvey, who says considerable research would suggest significant reductions in jobs within the next 20 to 30 years due to advancements in AI and robotics. What are the views of the panel? So I'd like to take this one round to everyone. It's a big question, but perhaps we can start with Sabine, please.
Sure. Thanks for the question. I think it's a really important question and one that we'll need to think about very carefully as we introduce these technologies so that we get it right. I think the data is currently unconclusive. So a lot of the research that's being done now is guessing basically what might happen in the future. And that's always something that's very difficult to do. And one thing I'd highlight is that very often what robots can do currently is tasks, not jobs. And so we're carving out small portions of what someone does within their daily job to be automated, perhaps to help them or to do something that's currently not being done in a way that's useful for that company. So those, I think of them more as tasks, and what tasks do we want to be doing as workers? What tasks don't we want to be doing as workers? And actually we'd appreciate help for it. And when we do our user studies, people don't, they don't tell us the parts that they want to replace a person with. They tell us about the parts that aren't currently being done or the parts that don't work. And I think those are places where robots will be really ripe because there's an unmet need there. Data-wise, a source of data from the International Federation of Robotics looked at jobs in the US as automation was introduced in the automotive sector. And the same data source showed two things. It showed both that jobs had increased overall in the sector as a result of the introduction of this automation. But there was also a big New York Times article that showed that one robot replaced 7 workers. And so there was displacement at the local level of what the tasks were being done from those individual operators. And I think it's understanding that nuance of what are we talking about? Are we talking about jobs overall? Are we talking about that the jobs of the future will be different from the jobs of today, which I think is the case? And what bits do we want the robots to do? I think we need to realize that people can be empowered to contribute to that discussion, to actually make a difference. There's a lot of work going on into this question so that we are mindful of that and that we get it right in the future, but it's something we need to think about.
Thank you, Sabine. And can I take that one to Manuel as well, please?
Yeah, so, well, this is a complicated question, so there's no easy answer here. I think there are examples where it absolutely makes sense to introduce robots. I've already talked about nuclear decommissioning, where we want to use robots to remove people from harm. Another example would be the care sector, and where we see, I think that the numbers are that in the UK alone, there's a shortage of, I think, already 40,000 care home workers, where it absolutely would make sense to, for example, use robots for logistics tasks or for tasks, everyday tasks in a care home, where a robot can use, for example, to clean, clean rooms or so, so that the people or the humans who are working in as caretakers do have more time for the social needs of the person's work living in care homes. So these are the areas where well, I personally would like to see more robots used, where you don't displace jobs, but rather you support the people working in these areas, either, you know, to support them, you know, so that they have more time to work on value creating activities, or to remove them from potential harm. And the other thing I would like to say is I think we should all lobby for governments to think about taxing proper taxes for work or for wealth that has been generated from using AI technology and robotics technology, and even people like Bill Gates, you know, promote this idea that that needs to be done something about you know, taxing work that has been generated by using machines. So that's definitely something where we should talk to lawmakers and governments and say, you know, we think that something needs to be done here.
Thank you, Manuel. And then finally to Nathan on this one, please.
I mean, so as you can tell from my views earlier, you know, I think that, you know, AI and robotics can be highly disruptive in terms of physical work, you know, in the next 10 or 20 years. So I think we can, and it's going to be, as I said, it's going to be really complicated how it's going to change the balance of work. Jobs will be created, some will go. It's not at all obvious how to predict it, but maybe we should reflect on how us, as a society, we as a society value physical work. You know, it's one of the things from the pandemic is, you know, if you remember at the start of it, everybody was like, hurrah to our supermarket stackers, you know, hurrah to our people doing physical work in hospitals. These people are on £15,000 a year or something like that, you know, and it was kind of, I felt it quite hypocritical actually, of how the media was treating, you know, the hurrah for these people, put their lives in risk so the rest of our society can continue. But we as a society don't value physical work very much. And it's likely that work will get displaced by robots because it's cheap work. So it's, you know, robots will be an economic decision about how a job can get done more quickly. And so it's unlikely that physical work will get displaced, in my view, unless you happen to be doing very well paid physical work, which the only one I can think of is a footballer, for example. You know, but I don't expect we'll be having robots playing football.
Thank you, Nathan. Let's not open that one up this morning. That's touchy enough anyway. So okay, I'm going to move on to the next question, and I'll take this one to Jonathan and then to Manuel as well for a bit. So Aaron Kisney asks, robots and software in particular are designed for mission-based deployment. What are the key barriers of robots that can operate for long durations in the real world without human intervention? So I'm guessing Manuel might have a different take on the last three words there anyway. So that's why I'm going to bring it to you. But perhaps let's take that first to Jonathan.
Yeah, the thing about robots operating autonomously for a long time is they really need all of the characteristics that organisms have. So you can think of a robot, instead of a robot, as a robotic organism. So it needs to have the capabilities to get its energy from somewhere. Okay, you can't just charge up your robot and send it out into the environment and hope it'll keep going for a long time. It's got to be able to get the energy from the environment. So that's scavenging energy from sunlight, from heat, from biological matter. That's what organisms do, right? They eat food, and there's an awful lot of energy in food. The robot has to be intelligent and adaptable because the environment is going to change. Hence, that's one of the reasons that robots fail, is the environment changes unpredictably. And finally, robots get damaged. And because robots get damaged, they need to repair themselves. So self-repairing robots and materials and structures are really interesting. This opens up a whole variety of really interesting things that could happen. You know, robots that collaborate together. I'm sure Sabine will talk about that. And robots that will potentially even, you know, share energy. Maybe one robot could eat another robot because it gets the energy from the other robot. And you talk about robot cannibalism. So this is all fun and exciting stuff in the future. But yeah, behaving more like organisms would be better for future robots in those environments.
Manuel, robots don't need humans, do they?
Of course they don't need humans. No, just kidding. But well, I have two examples, concrete examples. So I know there's some research on human-robot interaction for long-term deployment of robots in without human intervention. So there's some research going on, for example, for robots, underwater robots that are used to take measurements under the ice in the Arctic and so on. So in the Arctic Ocean. The interesting question there is, how do you give the robot the instructions to, for example, return when the robot is running out of battery, or how do you tell the robot how to determine when it is necessary to return back because the communication is lost or so. So there's some interesting research there. But just to say, so you would think that from an industry standpoint, it is necessary to have robots that are deployed long term without intervention. And we thought, so when we started our work with the nuclear industry, that they would have this requirement that the robot is always, autonomous and safe and so on. But actually, so at least from the nuclear industry, we see that they absolutely have a requirement that you always want to have a human in the loop, and for safety reasons. And I have the feeling that this is the case for probably many other industry areas. So what I'm trying to say is, I think this is less of a real problem than one would think, to have robots running without any human intervention for really long periods of time. Of course, robots need to have some autonomy in certain areas, especially flying robots or robots that are deployed where they are out of reach for humans, but it's not as big of a problem as one would think, I think.
Thank you, Manuel. And finally, on this question is to Sabine.
I was going to comment on the fact that swarms, we're really thinking about how to get them out into the real world for things like environmental monitoring or monitoring forest fires, which obviously then we need to think about how long can we get them out in the field, could they biodegrade if they lose them? But actually, Arthur, I think you're probably better to comment on that from the aerial robotics perspective. So I thought I'd send that back to you.
Sabine, you've freed me from the shackles of chairdom. Thank you. Okay, I think it's a cracking question, because it brings in an awful lot. Because I think with longer duration comes kind of longer context. And for me, I think rather broadly than just aerial robotics, and think in terms of sort of autonomy for robotics in general. And I think the key to surviving a long time in the real world is to adapt to what you find, and that includes people. That includes finding new forms of behaviors and different ways of doing things. You've just got more life. And so for me, then, the big challenge to achieving that from the kind of autonomy and control point of view is managing the safety of that adaptation, because I think we want robots that can surprise us, in the sense that, like, well done, I wasn't expecting you to last this long, or I wasn't expecting you to be able to cope with that. But your colleagues can do that, right? That's kind of the joy of having a human colleague, is that they can show initiative and things like that. So we want robots that can give us positive surprises and therefore last longer and do more than we want. But we don't want them that can shock us. So I don't want something which is like, what do you mean you went off down the road and you ended up doing this? That's not safe. Or was it? So the challenge for me is that barrier about getting the level of surprise that comes with adaptation just right. And that is a huge question, because AI as we know it at the moment doesn't easily or obviously lend itself to saying, well, let's box you in and make you safety proof. And I feel like that safety of adaptation angle is my pet barrier there. Anyway, thank you for freeing me for that moment, Sabine. So and thank you to all our audience members for all the questions. I'm going to close. So we've got a few minutes before we close. And I'm going to ask a closing question of all our panelists then, because I haven't seen you fighting enough. So I think Sabine nicely sort of mentioned something about saying the next frontier was, I think, making the most of bio-inspiration. I think, Nathan, you very strongly pushed that the next revolution was dexterity. Jonathan and Manuel, both of you have made very clear statement about the next frontier was ubiquity, or the next frontier was smooth human interaction. My question for you is, can you all be right? And if not, who is? Oh, everyone wants in. Okay, let's go to Jonathan.
I think everyone put their hands up saying I'm right. So yeah, I think you could say ubiquity, but I mean, I think you can view our environments and you can look around and you can say, where are robots going to be? And they're going to be around us, and they're going to be on us, and they're going to be inside us. And they're going to be in environments where we can't see them, because they're remote, in the Antarctic or wherever. So yeah, they are going to be everywhere. And I put my hand up and say that is the kind of the great cool thing. To get there, we've got huge amounts of challenges, right? And that's going to take 10, 20, 30, 40 years to get there. But that's the amount. Just coming back to Kevin's question about are robots going to make us all redundant? I mean, I think one of the things that we're all looking at the next 10, 20 years is that it's not robot future, it's human future. And so the next generation of industry and living and environments is going to be us at the center always. And that's probably going to mean that we are going to keep our jobs because we'll be driving that.
I wanted to say that I think all those futures are possible, and they only make sense if we interconnect them. So the robots of the future will be multi-robot, dexterous, soft, and will need humans in the loop to work. And so part of making this happen is to figure out how we can share. So what's the how do we build digital twins so all of our tools plug together? How do we build, living labs, test beds that everyone can play with? And I think that's also one way in which we bring our partners in industry to see what these techs can do when they're all connected.
We'll go to Manuel next, and then finally to Nathan.
I don't think that the challenges that we have raised are excluding each other. So I mean, that's one reason why we all work together in the Bristol Robotics Lab, right? I think robotics is interdisciplinary in its nature already. So it brings together people from different technology areas and people from the humanities and so on. So and that really shows. And I think, because robotics is interdisciplinary, we will be able to, hopefully work together and in the future and solve and integrate all of these challenges into one thing, as Sabine said, where we have a soft robot, ubiquitous robot that is able to interact with humans in the future.
Thank you, Nathan.
So again, I'm going to violently agree with everyone. So I mean, these things are all intertwined. So in terms of robot dexterity, the only example in the animal kingdom of a universal manipulator, the human hand. With that, we have transformed the world around us using our hands. All technology stems from our hands. It's ultimately something we built by hand, and then it's been through cycles to get to the advanced technology we have today. The human hand, robot that based on the human hand, is obviously bio-inspired. The human hand, it's soft. Our human hands are soft. The intelligent, our hands are physical intelligence, morphological intelligence in how we use them, as well as obviously the intelligence in our heads for how we use them. And they're parts of a human. So obviously, human robot interaction is key and will be key for interaction with other individuals when we have those robots with those dexterities. So it's combining all of that to lead to our, if you like, revolutionary robotic future.
Thank you very much, Nathan. So we'll draw our session to a close there. Again, thank you very much to the audience for joining us this morning, and for particularly for those of you who asked questions. We hope we've had a stab at answering them for you and given you some things to think about. Great thanks as well to the panel for giving up their time this morning and opening their offices and living rooms and wherever to share their thoughts with us. I appreciate it. Means it's not as interactive as we might normally like these kind of events to be, but I've enjoyed the kind of the to's and fro's we've had. So thank you for that. If you've enjoyed what you've heard today and you'd like to know more, or you'd like to know, or you find it more interesting, then there will be a follow-up afterwards this. So you'll be sent some follow-up details from the Industrial Liaison Office, who've organised the showcase for the week. So there'll be additional information from there. So all the members of the panel will be contactable through the ILO. So please get back to the ILO if you have any follow-ups or interests. There's also a big follow-up event coming for robotics in particular. So on June the 30th, the Bristol Robotics Lab will be holding its annual conference, which will be it's going to be another online event. We don't think the world will be to the point that by then that we can have you all at the lab, but nevertheless it'll be a much longer event and a chance to hear much more from the colleagues you've met today, and also from the many more colleagues and working in other areas at the Bristol Robotics Lab and in that community. So in details on that will also be in a follow-up you get from the Industrial Liaison Office. I think that's all from us. That's all from me. Thank you all very much for joining us.